Active versus passive intake made by 22012 FTC loose screws. My name is Shrey and I'm one of the builders on the team, and I'm going to be basically explaining to you the differences between them and pros and cons of them. Alright, so what is an intake? So an intake is a subsystem intended for collecting game pieces from the field, and there are two major categories of intakes: passive, which is a claw, or active. And last year we used a passive claw, which is shown in the middle, and that's from the center stage season. And also another example of a passive intake would be the Looney Squad claw from the Power Play season. An example of an active intake is the gluten-free intake, and that's from a different season as well. So, what is an active intake? So an active intake is a mechanism built to grab game elements through rotating wheels, tubes, or flaps. And an active intake is comprised of power-driven components, which means that it's powered by motors or servos or both. And a good thing about active intakes are that they're extremely adjustable, which means that you can adjust them in real time based on sensor feedback or manual control. For example, rollers can change speed and conveyor belts can reverse directions. So active intakes also have continuous operation, which means that they can run continuously to ensure consistent collection, even when the robot is moving at different speeds. This is extremely helpful for last year's game, right? Because you had to roll over the pixels in order to grab them, which was extremely easy. So an important concept to know about is the fact that when you touch the element, you own the element. And that's extremely important when deciding on whether or not you want to make an active intake. And a less known fun fact is that four out of the four robots in the FTC Center Stage final had an active intake, which is pretty cool. All right, so some examples of active intakes include tubing intakes, which means that they use rotating rubber or foam rollers to grab game pieces from the floor. And there's a lot of options on how to make these, which include 3D printing TPU, polyurethane tubing, or surgical tubing. And these all have various stiffnesses and diameters. And they're effective for uneven surfaces and different piece shapes, like the ones we have in this year's game. And they're able to be collected. You're able to collect multiple pieces at a time, but it requires a high RPM. So you can see the boot, which is the wheel. You can see the boot on the right, which is the wheel intake from our Into the Deep robot from this year. What we have is if you go into the submersible and you put the intake on the sample, then you have to rotate the wheels in order to get the sample, which is extremely helpful and easy to do. So another example is a conveyor system, which is when you have a conveyor belt which consists of moving belts driven by motors and servos. Another example is a compliant wheel intake, which is useful for large game elements and can account for various orientations. So you can see on the right the tubing intake with the surgical tubing and an example of a conveyor belt taken from FTC 2827. So what is a passive intake? So a passive intake is a mechanism that requires individual items to be picked up using a gripper of some sort. And the most common passive intake is obviously a claw. And most other passive intake designs, they're not really helpful in FTC, or they're not common either, because most of the things that you need, like the elements, they're just taken by claws. And so passive intakes are simple and lightweight, which means that they're lighter and simpler to build than active intakes. Less time to build can be made more reliable. This is an important part of passive intakes. So a claw often doubles as a collection or score mechanism from Power Play with the cones. And it works well in games where there are less elements to pick up, games with odd-shaped elements, and games where the elements have minimal orientations. When looking at examples of claws, we have to focus on the claw mechanisms. And so claws feature two or more acuted arms or fingers that close around a game piece, and they're actuated by servos. They can be designed with various finger shapes to enhance grip, and they can be opened or closed depending on the collected piece size. And the drive team has to position the claw specifically to grab the element. And back 2 years ago during the Power Play season, I was the driver for our robot, and it was extremely easy to just rotate the claw around and grab the pieces, and it's extremely helpful. And you can have multiple degrees of freedom, and you can also be used as an outtake, as you can see from the solver's claw and the insert claw. You see here in the solver's claw that it has multiple degrees of freedom because it's able to be rotated 180 degrees, which is helpful in this year's game. And looking at last year's game, the insert claw is helpful because you put the two screws into the pixels and then you lock them in, which keeps them there, and then you're able to release them when you're on the backboard. So let's look at the key differences between active and passive intakes. So focusing on the power requirement, active intakes are powered by servos and or a motor, while passive intakes can only be powered by servos. So looking at the mechanism complexity, active intakes are typically more complex while passive intakes are generally simpler, just like a claw. And on the precision, active intakes require less precision from the driver because, as I said before, you're just like driving into the actual element, while for passive intakes, you have to align with the game element. Looking at the speed, active intakes are often faster, while passive intakes are slower because you need more driver precision, obviously. Looking at the adaptability, active intakes are more adaptable to various shapes and sizes, while passive intakes are catered to one specific element. So they're important in games where there's like a weird design that you need to get or something. So also looking at the maintenance, active intakes have an extremely high maintenance because they're extremely complex. So you have to make sure that you know what you're doing with them, or else it's going to break. And passive intakes are also fragile actually. So looking at the pros of active intake, the fact that it's really quick allows for rapid collection of game pieces, crucial in fast-paced competitions like robotics. It's also extremely versatile and it can pick up several different shaped pieces. It's also very precise and it enables fine-tuning of how pieces are collected, such as adjusting speed and grip strength. And it's also easily customizable because many options can be perfected to work with whatever robot design you want. Looking at the negatives of active intake, it's extremely complex and a lot of testing is required to perfect the design. Last year, for our active intake, we had to test a lot just to get it to work properly for our state championship. Alright, looking at the weight of the active intake, it is really heavy, which can impact the robot performance by making the robot a little bit heavier, which is bad. Um, Focusing on the power of the active intake, you need to utilize a valuable motor slot, which you don't really want to do, right? Because you want to keep all the motor slots for other stuff that might come up for your robot that you need to be powered. And focusing on the geometry, you need to make sure that your active intake is only capable of grabbing the allowed amount of elements because you don't want to grab more than how many are allowed because that would be a penalty. All right, looking at the pros of passive intakes versus the cons of passive intakes. Passive intakes are extremely simple and they're easy to design and test, which gives you more time for refinement to make it better. They're also lightweight, which contributes to a lighter robot. And they're also energy efficient because they're just powered by a servo. And it also has complex movement, which, if needed, you can add more degrees of freedom, right? As we saw from the other claws that I was showing. Looking at passive intakes, cons, they're slower than active intakes, which can affect the amount of points you score, which can decide if you win a match or lose a match, obviously. And there's only limited adaptability because you can only have one claw using to pick up one element, and if you have games with multiple elements, this can be a big issue. So another con with passive intake is the high reliance on your drivers being able to be precise because if the drivers aren't precise, you're going to miss the element and it's going to take you more time just to grab it. And also, passive intakes are more fragile than active intakes, which isn't that good. So, in summary, it's important to choose between active and passive intakes and make sure that when you're choosing, it should align with team strategies and robot designs. Teams should consider factors like speed, adaptability, and maintenance when selecting their intake systems. A well-designed intake system is crucial for each game, and if you have any questions, just shoot us an email at ftc22012@gmail.com.